Hi, Assalamualaikum. Our title project is Analysis of the Relationship between Lecturer and Students' Academic Performance using Fuzzy and Nitrosophic Relational Maps.
Assalamualaikum. Hi, my name is Narayana binti Mama Arman.
Hi, my name is Tihani Bajisha binti Abdul Rashid. I am pleased to introduce our lecturers, Dr. Nurarida, Dr. Hazwani, and Madam Fitria.
For introduction, first, research background. Fuzzy set, introduced by Zadeh 1965, assigns membership values between 0 and 1. After that, Nitrosophic set, developed by Smarandage 1999, handle uncertainties beyond fuzzy set and intuitionistic fuzzy sets. And lastly, for fuzzy cognitive maps, introduced by Bart Kosko, 1986, combines fuzzy logic with cognitive map for causal reasoning.
Fuzzy rational maps, FRMs, are graph-based representation of concepts, nodes representing elements and connection as edges. So the fuzzy value of each edge is true and falsity. And nitrosophic rational maps, NRMs, is same as fuzzy rational maps, but the nitrosophic value of each S is different, which is true falsity and it has indeterminacy.
Online distance learning, ODL, has become crucial due to the COVID-19 pandemic, but it has not fully satisfied learners' academic achievement.
The problem statements for this project is the COVID-19 pandemic has emphasized the importance of online distance learning in teaching and learning for lecturers and students as well. It is because all of us need to learn how to use the technology in aspect of learning. Research from Raja Durai and Hanafi 2018 suggests different delivery and assessment methods can improve student satisfaction and academic performance in ODL. However, existing methods like combat alpha cannot cater the indeterminacy information. This gap in research is particularly evident when it comes to studying the relationships between lecturers and students in the context of ODL. Therefore, this project aims to analyze the relationship between lecturer and students' academic performance of ODL using FRM and NRM, and the comparison results of both methods can be analyzed. Scope of project focus on the FRM and NRM, where these techniques are applied to study the relationship between lecturer and students' academic performance of ODL. Then a few ideas and conceptions are developed in the study based on experts' opinion, which involves the participation of two experts, which are one lecturer and one student on UiTM Macang campus. Additionally, some directed graphs have been designed, followed by relational matrix. Next, methodology. These are the list of our domain and range. So there are 8 nodes related to lecturer in teaching ODL as the domain space from D1 to D8, and 5 nodes related to a student's academic performance as the range space, ranging from very high to very low performance. So in this project, we have 2 cases for hidden pattern, which is case 1 is when we use the first domain, D1, which is lecturer give a clear instruction. Meanwhile, case 2, lecturer give an unclear instruction. But we only show the case 1 only since it used the same process. The result will be compared to see the difference between case 1 and case 2. Okay, for FRM, this flowchart shows us the process of finding the result. After we conduct a questionnaire session where a respondent of one lecturer and one student in UiTM Macang campus, data will be collected and constructed into relational directed graph and relational matrix, which include only 0, -1, and 1. After that, we need to find hidden pattern and multiply it until get the fixed point.
Okay, for nitrosophic relational maps, we can see the method is the same as FRM, but it is slightly different in step 4. The data will be collected and constructed into a relational directed graph and a relational matrix, which include 0, -1, 1, and I, which is indeterminate.
Our first expert is a lecturer and has about 3 years of experience in her field in UiTM Macang campus. From the data of questionnaire, we transform it into directed graph and relational matrix, which is matrix 8 for the first expert. Case 1 is when we let D1 equal to X0 equal to on equal to matrix 1 by 8, where only D1 is 1. After that, we need to multiply it with matrix that is transposed, which is A power of T, to get Y0. To get Y0, after the multiplication, we need to threshold the matrix where at D1 it will always be 1. And when we get positive constant, we will threshold it as 1. And if we get negative constant, it will be 0. After we get Y0, we need to multiply it with matrix A to get X1. The process will be repeated until we get the fixed point, which is when we found the matrix that has been calculated is repeating the same matrix. So in this case, the fixed point is x2 because x3 equals to x2, same with y3 equals to y2.
This is the directed graph and rational matrix for NRM on the first expert, which is lecturer and has about 3 years of experience in her field in UiTM Macang campus. So from the directed graph, we can see that it has dotted arrow, which is represent the indeterminate.
Same on NRM on the first expert. First, we let D1 is equal to X0, which is in on state. After that, we multiply it with rational matrix transpose. We get the result, which is Y0. After that, Y0 multiply it with rational matrix, and we get the result. After that, we threshold and we get the X1. repeat the calculation until we get the fixed point, which are x1 and y1.
Okay, so this is the result and also the comparison. So in comparing FRM and NRM for case 1 with key instruction. So FRM provide clear impact delineations and while NRM center at x1 and excels in handling uncertainty.
Conclusion and recommendation. This study at UiTM Macang campus has explored how lecturer-student interaction in online learning impact academic performance using FRM and NRM. It shows that certain instructional variables significantly influence academic outcomes, including clarity of instruction, responsiveness to inquiries, online participation, and engagement with assigned tasks. The Nutrosophy approach helps understand complex relationship better. Future research should focus on practical application of FRM and NRM in real-world systems. This project commercialization potential lies in its ability to enhance online learning experiences where it improves student-lecturer interaction in ODL using FRM and NRM. Second, it also can be marketed to educational institutions looking to enhance their online learning programs, offering consultancy services or software tools for implementation. Lastly, for consulting service where it can help institutions effectively implement FRM and NRM approaches, ensuring optimal result in online learning environments.
While FRMs excel at handling fuzziness, NRMs offer a more comprehensive approach by also addressing indeterminacy, providing a richer toolset for analysis in uncertain environment. That's all from us. Thank you.